Howdy and welcome back. So we'll begin today's lessons content with a brief kind of recap of the differences between a standard library unique pointer to that of a standard library shared pointer. If you recall from our introduction to smart pointers lesson, we introduced four smart pointers that we said were available to you since the C++ 2011 standard was released. We said that there was the unique pointer, which we'll recap today, the shared pointer, which will provide not only recap, but also provide a naive implementation of. And then we noted the weak pointer, which we mentioned we're not going to get into too much detail into this class. The final smart pointer that we introduced was the auto pointer, which we said has been depreciated, and it was introduced in the C++ 1998 standard, and that the only reason to employ this smart pointer was if you, for some reason, needed to compile code with that standard of the programming language. So recall that a unique pointer was a pointer that would retain exclusive ownership of an object through some sort of pointer that it stores as a data member. So remember, these smart pointers are kind of wrappers around around a pointer that's pointing to some sort of dynamically allocated object. Let me draw this out real briefly. So you can kind of think of a unique pointer as being defined as such. There's some sort of public interface, which is going to govern our access to a private raw pointer to the resource for which this owns. We said that copy semantics were disabled because of the fact that this pointer here owns exclusively the object that is being pointed to through holder in this diagram. And if we were to say initialize another unique pointer or even assign one unique pointer to another, that's kind of violating our assumption of ownership unless that assignment or construction constituted a resource transfer, as we saw with the move semantics. So it is totally okay to transfer ownership. However, there will not be any sort of copy semantics that will allow you to introduce some sort of way that is going to violate this idea of the exclusive ownership. So there's, I think we showed the interface to this. Let me just pull this up quick to kind of recap it with you. So sharing a different screen here. If you wanted to, read more about the unique pointer and look at its public interface, see what those functions do, you can use CPP reference, and it will go ahead and explain a little bit about the type, some of the information in terms of how it's defined, where it's defined. Remember to use these smart pointers. It's a pound include memory. And then here's the member functions that are available to us. We see the constructors, we see a move assignment operator, we see some modifiers, which we briefly touched on in the introduction to unique pointer video, observers, etc. So let me hop back over to our slides, and now we'll go ahead and move on to the unique pointer. So remember, this is exclusive ownership. So the unique pointer would be responsible for acquiring and releasing some sort of object. Now, a shared pointer is going to allow, as the name implies, some sort of shared ownership of an object through a pointer of the shared pointer type. And this will be kind of constructed similarly to that of our unique pointer, in that a shared pointer is going to be but a wrapper around a raw pointer object, and it's going to enforce certain interactions with that pointer to the resource through its public interface. We'll see here that no specific shared pointer will own the object. Instead, it will be shared across them, and it will be the responsibility of the last shared pointer standing to go ahead and perform the deallocation of the resource that the object is pointing to. Therefore, the data members are set up a little bit different in the operations defined as well, and from a different perspective to support this shared ownership. So copy semantics will be a thing with the shared pointer, and the idea here is that by initializing one shared pointer with an object of the same type, we're going to introduce this concept of ownership of some sort of resource. How this is going to be laid out is a standard library shared pointer will have two data members. One is going to be a pointer to the dynamically allocated object for which uh, the, that is shared amongst some number of shared pointers. And then there's also going to be a pointer to a control block, which is going to maintain some additional information. And both of these will reside on the free store because, again, we would like to exclusively manage their lifetime and not, if one shared pointer goes out of scope and the control block was defined as a data member within it, that's going to perform a deallocation of the control block when we want these two things to be shared across all of the smart pointers who are engaged in the sharing of this T object here. So what we'll see is the copy semantics do result in a shallow copy. So multiple shared pointers will have the same address stored in that holder variable as well as the same address to some sort of control block, which will contain some housekeeping information describing the shared nature of the resource. For instance, how many shared pointers currently point to our T object is going to be one count that is going to be stored within the reference block. There are a couple of other things that are also stored and managed by the control block, which we are going to ignore for our purposes of discussion today. If you recall, we did introduce this idea of a weak pointer in the introduction to smart pointer reference. We'd see that they're set up in a manner that actually resembles the shared pointer in terms of the data members that it will have, except that the weak pointer did not increment the reference count. It instead incremented the weak count down here. But we're not talking about weak pointers today, so do not worry about this. Again, our focus will be on this portion of the control block today, the reference count, and then also the resource that is shared across potentially shared across different shared pointer objects. And how you might think of this is upon initial construction of a shared pointer, it's going to, so think construction. We're not talking about copying here. We'd go ahead and acquire the T object that's being pointed to here, and we'd increment the reference count by 1 to show that there was a single shared pointer pointing to that object. And then if we were to initialize another shared pointer with that pointer that we had just created, well, the copy semantics are going to be defined to engage in a shallow copy so that the resultant object that's being created points to the same T object and the same control block. Also, what we'll see here is going to happen is in our definitions of our copy policies, we're also going to increment the reference count by 1. Likewise, in the destruction of any sort of shared pointer object, the reference count is going to be decreased by 1 because one of the pointers pointing to the shared object has gone out of scope or its lifetime has been over, and only when the reference count is 0 will the control block an object have its memory deallocated for it. And I'll go ahead and point out that we went through that. I crossed it out last time. I said, well, it's not quite that way because there's this also weak count that might have to stick around. So the object would be deallocated when the reference count hits 0. The control block would be deallocated when the reference count and weak count is going to hit 0 because these are the things shared across both shared pointers and their intimately related weak pointers, which afford some additional functionality, which again, we won't get to too much in this class. But again, I hope you see what's going on here. We're creating objects, so shared pointers, which each are going to have a pointer to some sort of object of type T, which will be acquired in the first time a shared pointer to that object is constructed. We'll have the ability to go ahead and copy that shared pointer, which will mean multiple shared ownership of that T object, as well as the control block. And only when that reference count gets down to 0 will the memory be released for T object. So let's go ahead and take a look at the actual interface of a shared pointer. So just hopping back over to the cppreference.com, we can see that, okay, there's, kind of a number of a brief description of our shared pointer. And then we get down to, what you all might be interested in is the member functions. We can see constructor, destructor, assignment operator. And then here's kind of the ones that you might be the behaviors that you might be more interested in. And there's a reset, there's a swap, and then there's a couple of observers, which one I'd like to point out is get, which is going to return a raw pointer to the object that's being held by a particular shared pointer. There's also a use count, which will tell you the number of, it essentially returns the reference count, how many shared pointer objects are currently referring or engaging in the shared ownership of a specific managed object, as well as an ability to ask a shared pointer, and this is introduced in C++ 2020 standard, hey, do you have one reference count? That is a particular standard library shared pointer the sole owner of the object or resource to which it's pointing? There's a couple of additional member functions and then some non-member helper functions, which are interesting. We're going to go ahead and in our naive implementation only consider a subset of the behaviors listed here, and we're not going to consider the full kind of implementation. Ours will be naive in many ways. However, what's important is that I think its essence will communicate more or less what's kind of going on through kind of this primitive implementation. So I think it will be a productive exercise, and if you wanted to extend it and make it more standard template library like, go for it. But it's there's some concepts within here which are beyond the scope of this class, which we won't get to, such as allocators and some others. So let's go ahead and jump back to the slides. I believe this was the second to last slide. Nope, I was wrong. Whoops. I don't think you all can see my scrolling. Oh, here we go. It's back. So we'll go ahead and now jump into our naive implementation of a shared pointer. We'll run through the motions to come up with something that's operating similarly in, again, a kind of primitive, naive way. And then that'll be it on shared pointers, and we'll see where we are on time. But I'm kind of thinking we won't get to the weak pointers, which is fine because these are the ones that I wanted to introduce, the ones that I wanted you to be familiar with. The unique pointer has a ton of utility for the data structures we've talked about. Shared pointer has an interesting design pattern, if you will, which I think is beneficial to kind of go through, as is this concept of unique ownership versus shared ownership of some sort of dynamically allocated resource. So let's get going on to the next one.